Using the chunking method for completing long division. In this video, we're going to have it when you have remainders, when a number does not go in evenly. Doing long division using the chunking method. On this video, we will be dividing a dividend by a divisor, which will not go in evenly, which means we would have either a remainder or we could convert the remainder into a decimal. Let's start with a question. 467 divided by 21. Remember, when we're doing our chunking, we're looking for large groups. So I'm going to go 10 times 21. And if I do 10 times 21, my answer is, as you may recall from the previous video, we're going to take and draw us a strange little line. I'm going to extend this out today because I know I have a remainder. And I'm going to draw it way down there. Okay? So, again, we looked at the divisor going into the entire dividend this time. Not doing it in little sections, but doing the whole thing. So, I'm going to say that 10 times 21 would be a 21 and a 0, 210, 7, 5, 257. I notice that 257 is still larger than my 210. So I'm going to take another 10 out. 210, 7, and I get a remainder of 47. Looks like I can take out 2 times 21. That would be 42. And I have a remainder of 5. Now I can take this question and I can add these up, and I could get my answer is 21 remainder 5. And that's great for elementary. But once you hit 5th or 6th grade, your teacher is going to tell you you can no longer do this as a remainder. If you're converting it to a fraction, this is no problem, because your answer would be 21, your remainder over your divisor, and that would be your answer as a fraction. So this method is really, really set up for elementary or saving a remainder as a fraction. Unfortunately, past the 5th grade, we always seem to want our kids to know how to do this and convert your your remainder into a decimal. Okay? And traditionally, I would take and add a decimal and add a bunch of zeros behind it. Okay? And I like that method when I do the traditional method. But in this case, we're actually sitting here and we are doing this new chunking method, or partial quotients, as I've heard it called now. Okay, so now that I'm back with this, all right, I'm going to do what I did a while ago. And I had 20 times 2, which was 420, 7, 4. And I had 2 times 21, which was 42. And it gave me my remainder of 5. Okay. At this point, I cannot continue the chunking method. At this time, I'm going to have to take and change over. So what I tell my students to do is put a squiggle here. Okay. I'm going to take and do this part here. That gives me 22. And my decimal will go right there, right behind that whole number. Okay. Right where my line goes up and down. You'll notice I've got it right in here. Okay. All right. Anything I do below this line will become my answer over here. So at this point, I'm going to go look at the traditional method. And I'm just going to add a 0. Okay. And 21 goes into 50 2 times. I'm not doing any of the crazy multiplying on the side. I'm doing this kind of old-fashioned now. And this is a 42. And I get a remainder 8. I'm going to add another 0. Okay. This 2 is going to go right here. I've got an 80. I think it's times 3. That would give me a 63. Okay. So my 3 goes here. Now I'm going to put a 0. And I believe, I'm going to guess that it's a 8. No, 8 would be too big, wouldn't it? Okay. Actually, 8 would be great. Okay. And 21 times 8 is 8 and 16. And I get a remainder 2. And my 8 is going to go right up here. Okay. Notice I did not add these up. This is the traditional method. From here on down was the regular old method. Okay? All right. So I had to do the guess, divide, multiply, subtract, and bring down. Okay? Not my favorite. You also will notice there's a remainder. The rule in my class is we never go past 3 digits behind the decimal. We never go past the thousands. Okay? In junior high math, we don't need to go any further. If it is necessary to have something larger than that, we typically would be using the calculator. So we will go only 3 digits. Let's look at another problem. Let's do something like 47 goes into 256. Draw my line down. Okay. And let's see, if I did times 10, that would be too much. So let's try times 5 times 47. That's 35. This is 20 plus 3 is 23. Subtract, subtract, and I get a 21. Okay. You'll notice that 21 is less than 47. That means I have reached the end. So my 5 is my whole number and include a decimal. Now it's time for me to go with that traditional method. I'm going to add a 0. 4 goes into 20 about 5 times. That's probably too much. I'm going to try a 4. 47 times 4, 16, 18, that works. So I'm going to say 4 times 188 is this. Borrow, borrow. Became a 10, became a 0, it became a 10, 22. Add a 0. Oops, sorry, my 4 went here. Okay. 220. Still believe it's going to be a 4. It's 188. 2 becomes a 1. Becomes 32 now. Add another 0. Now I've got 3,200. Let's try a 7. 28, 29, 30, 31, 32. Too big. So, pretty sure this will work. 24, 28, 282, 8, 11, 3. Okay. And so that one was a 6 is what we ended up using for it. Okay. All right. Again, I'm only going 3 digits, so I will be stopping my answer there.